Hi everyone, welcome back to my channel. My name is Shreyanshi and this is our 6th lecture of the CSE 101 playlist. So today we are going to talk about recursion as it is a really important topic for someone who is aiming to pursue computer science. Okay, so let's start our lecture. Yes, so what is recursion? Recursion is basically a function that calls itself. So for example, what is this fact function? This is factorial. So we all know that factorial of n is equals to n multiplied by factorial of n minus 1, right? So here just the arguments are different. This is n and this is n minus 1, but the function fact remains the same. So that's what it means that factorial of n is calling itself. See? So that what it means by recursion. So now let's see an example to understand it better. So here we have written a function in Python. So def factorial of n. Now if n is equal to 0 or if n is 1, so then we will return 1 because factorial of 0 is also 1 and factorial of 1 is also 1. Otherwise we'll just return this function that we have written here, right, this equation. So we will return n multiplied by factorial of n minus 1. So that's how we write a recursion function. This is called a base case and this is our actual recursion. Okay, so if we print factorial of 5, so we will get the output as 120. Now let's see how this works. Okay, so let's assume this f of 5, which means the factorial of 5. So how will the call work? Now see, n is not yet 0 or 1, so our base case is not satisfied. So what we will do? We will return 5, which is n multiplied by factorial of 4. Okay. Now for f of 4, is 4 equal to 0 or 1? No. So again we will give 4 multiplied by f of 3. Is 3 equal to 0 or 1? No. So we will return 3 multiplied by f of 2. Is 2 equal to 1 or 0? No. So we will return 2 multiplied by f of 1. Now see, we have the value of f of 1, right? Because it is satisfied in our base case that if n is equal to 1, we will return 1. So now this will return 1. So what's 2 into 1? That's 2. So this will return 2 for f of 2. So then 3 multiplied by 2 is how much? That is 6. Now for 4 into f of 3 is 6. So 4 6 are 24. And then this is 24 here. So 5 into 24 is how much? It is 120. Right? So that's how we get this answer. Okay. So let's take another example now. So this is the Fibonacci sequence, okay? So what is the Fibonacci sequence? The first two terms will be 0 and 1, and then what we do is we just add the n minus 1th term and the n minus 2th term for the nth term. So for 2, for this second place here, we will just add 0 and 1. So that's 1 again. Now we will add this and this. So 1 plus 1 is 2. Then for the next term, we will add this 1 and this 2. So that's 3 and then so on. That is a Fibonacci sequence. So what is the recursion equation for that? F of n is equals to f of n minus 1 plus f of n minus 2. And what is our base case? These two are fixed, right? The base case means that only, that some number is fixed and then the coming values we will find through recursion. So that is what is it, that if n is equal to 0, we return 0. If n equal to 1, we return 1. So if n is less than or equal to 1, we will return n. Okay. So that is what is written here. So for Fibonacci of n, if n is less than or equal to 1, we will return n. This is our base case. And otherwise, we will return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So if we want to print the first 6 terms, so for I in range 6, we will print Fibonacci of I, and then the output will be this 0, 1, 1, 2, 3, 5. and you can try creating the recursion tree just like we did in the previous example of the factorial. Okay, now let's understand something super important. Yes, so why is recursion not the best approach all the time? Let's look at it by this example of the Fibonacci sequence. Okay, this is Fibonacci of 5. Now for getting that we need to add fib of 1 and fib of 3, right? Because f of n is equals to f of n minus 1 plus f of n minus 2. Now recursion works in DFS. So this tree will be traversed like this. Okay, that's how this tree will be traversed. Depth first search. Finding Fibonacci of 4, we will need fib of 3 and fib of 2. Now for fib of 3 we will need fib of 2 and 1. For 2 we will need 1 and 0, and then this will be our base case, so it will return the values directly. Now can you see that this subtree and this subtree are one and the same, right? We can see over here. And also this portion of the subtree is also repeating over here and also here. So we are having repetitive calculations, right? So if we have calculated Fibonacci of 3 once, then why would we do it again when we are traversing this right subtree? Recursion will calculate it. There is no way of overcoming that. So that is why something called dynamic programming was introduced to overcome this shortcome of the recursion, right? Which we will talk about in the next lecture. So please stay tuned until then, and I hope you liked this lecture. Thank you so much for listening to me till the end. I hope you have an amazing day. Bye. Don't forget to like, share and subscribe to make this beautiful grandma happy. Bye.